Thank you so much, everyone, for being here. Again, hopefully, I think everyone knows me already, but my name is Kevin. I'm going to be teaching you guys today about a little bit more about the EVM, which is the Ethereum Virtual Machine, so you guys can get an understanding of how it works. And then we're going to talk about Solidity, which is the primary, I would say, the most popular language used to write smart contracts on the EVM on Ethereum. There is another language called Viper, which is somewhat gaining popularity. It was mentioned by Vitalik today on his speech here at DevCon. So for all of you that are listening in, I'm actually at DevCon in Thailand. Today is their kind of main event and a lot of cool excitement around Ethereum. So if you guys are interested, check out the Ethereum Twitter and the Ethereum YouTube, and there's a lot of good content there. But today, we're going to be talking about the EVM, and we're going to be talking about Solidity. And we're also going to, maybe if we have time, we'll try to maybe look at the challenge from yesterday and see if we can kind of show what was supposed to be done. But let's kind of go from there. I'm going to go ahead and share my screen. So hopefully everyone here has this Notion page that I shared out. I'm actually going to bring it up here in the web browser. It's a little bit easier to view. When we met last time, we did a very basic introduction to what it means to build on Ethereum. So we covered kind of like section 1. The ask was that you go through all the content, watch all the videos, and then try to complete Speedrun Ethereum Challenge 0. Hopefully you guys were able to at least do that. Please use the Discord to ask questions. We are going to have a questions and answer session coming up so that we can get people up to speed, but please feel free to do that. But today we're going to be focusing on session 2, which is the EVM and Solidity workshop. So it's mainly going to be at first just a lecture on what EVM is, how it works, very high level kind of overview, and then how the syntax looks and what kind of functionality you can do with Solidity on the Ethereum Virtual Machine. And then we're going to do some actual like workshop steps where we're going to use Scaffold ETH to write some code and then test that code and kind of see what that process looks like. But essentially, the Ethereum Virtual Machine is a world computer. So the most popular way to think about it is in a Ethereum network, there are thousands of networked machines that are running, and all of them are combining all of their power to create a single computer, a single endpoint. And this is executed by having a certain amount of ability inside of each node to execute code. So it's almost like having an application server. Like if you were running a node server, then you were running an API in Node.js. Or if you were running Go and you're running an API or Ruby on Rails or whatever. But essentially, it's distributed. So it's a distributed system. So in order to keep that secure and safe, you need a way to execute things inside of that virtual environment in a safe way. So that's why it is a virtual machine. It has immutable read-only memory, and then it has some machine state, which is the volatile aspects. So it's where things are actually executed inside of the virtual machine. And then it has more persistent state, which is more like the storage and the database aspect of what Ethereum is. So you can think of it like a way to take in inputs, process those inputs using cryptography, and then get that output back out and save it into the state. We talked about that a little bit before, but that's what a blockchain is it's a chain of states, right? So it's kind of like if you made a change to a database table, as it changes over time, we create this chain, right? And so the Ethereum Virtual Machine is exactly that. It allows the execution of smart contract bytecode, and it allows you to keep track of what's called nonces. So it has a counter, which keeps track of how many times something has changed or been modified. And then it has this kind of stacked-based system to read and write from memory. So it's a stack-based system. So you can write memory and then read memory in this kind of like stack. So you put it on and then you take it off and read it. So it's a little more in-depth than you guys need to know, but it is a stacks-based system. it has this concept of gas, right? Because it is an Ethereum virtual machine, it has a native currency called Ether, and that Ether is what powers the network. So you pay some what is called WEB, which is the lowest denominated value of Ether for a gas transaction to change the state, and that's what keeps the network secure and keeps the network running. And then you also have memory that you can access inside of that machine state as well. So this is a more detailed overview of what that is. But again, you can think of it like this. If you are a developer, you would normally write some code and you would deploy it on an application server. In the case of Ethereum, you write some code and you compile it down and you push it to the blockchain as storage. So you actually store it. It's almost like the Ethereum node is acting as a database that stores all of the execution code, the EVM code. And then therefore, if you want to make a transaction with that code and call the functions and read the variables or update the state, you do that using an RPC call. So it's just an API call into the Ethereum virtual machine. And we'll talk a little bit more about that, but essentially you're making a call in. And then you can do these operations, right? Like call a function, update a variable, and this is all done using that stack-based system I mentioned that updates internal memory, and then also in turn updates the actual storage outside of the transaction. So it's called a transaction is what we call it. And essentially, yeah, you just pay this gas to either store stuff or you pay this gas to update that storage in that state. So there's different kinds of storage. There's account storage, and then there's contract account storage, and then there's like balance storage, which keeps track of how much assets that a particular user has. So there's lots of different things, but this is the high-level overview of how that works. You don't need to know this too well for this entire curriculum. This is a little bit lower level, but it's good to understand at least what you're doing when you're building an application. So Solidity, which is the most popular programming language, again, is a very high-level language, which means that it's very easy to read and it's very simple in the sense that you have the same kind of functionality where you can specify required version, which is called the pragma in Solidity here, and you can specify a range of versions as well. So you can say that when you compile this, you compile it within a certain range that's available on your system. So Solidity has many, many versions, but the most common version used today is 0.8.24, I think, or something like that. Solidity does not get released very often. It's a very low developed programming language because it is very simple and there's not a lot of bugs in it for that case because it's very susceptible to, if there is a bug, it could cause some serious issues because there's so much finance aspects to execution in this environment. So again, it's very simple. So as you can see, we have this here, we have a contract that's called Hello World that has a string that is public called hello, and then that string is hello, comma, world, which is an actual string. And then we have a function that's called shout that you could call. And if you were to call this on the smart contract, you would get back, you would return the value of a string inside of memory as this value. So in this case, we have the variable defined as hello. And if we were to call shout, by making a transaction to request that function, we would get back the string. So it's, again, it's an input, you request what you want, and you get back the data that you need. So it's very simple. It's very easy. If you've programmed in any language, Solidity is fairly easy to pick up. There are some just little nuances, but hopefully by the end of this, you'll get an idea of how it works. So we talk about this high-level language, right? It's a very high-level syntax. What happens is when you write your high-level code and you deploy it onto the blockchain, you first need to compile it. So it's kind of like it's compiled down into what is called bytecode, which is very hexadecimal ones and zeros and alphanumeric characters, and it's not really very human readable. It's kind of looks like gibberish. And so that is what's stored on the blockchain. And so you write your code, you compile it, and then when you compile it with the compiler, which is Sol C in the case of Solidity, it creates this thing called an ABI. So basically an ABI is kind of like a map, like a treasure map to understand the bytecode. So you can think of it like if you were in a foreign country and you didn't understand the language, you would probably use a dictionary or you would use some kind of translation app to interface with people. The same goes for Solidity. When you write it and compile it, you need to be able to interact with it and understand how to speak to it and how to read from it and understand it. And that is done by the ABI, which is called the Application Binary Interface. So again, this is not stuff you necessarily need to know right away, but it's an important concept because you're going to probably reference the ABI as we go through this course. So it's good to understand that. And basically the ABI is just a JSON object. So it's just if you're familiar with JSON, hopefully JSON is just a JavaScript orientated notion or like a structure, and it just has all the details about what that smart contract is. Then you deploy it, right? You deploy the bytecode. And so this is kind of what it looks like. You can think of it if you're a developer, you write some Solidity code in Solidity. You deploy, well, first you compile it down. And when you compile it, it gives you the bytecode and it gives you the ABI on your machine. And then you deploy just the bytecode to the blockchain. So the ABI doesn't get deployed to the blockchain. The ABI is just a artifact that you need to be able to understand that raw data. And so you deploy it. And then when you want to read it from your application, you need to have that ABI to understand how the data is coming back off of the blockchain. So in other words, if you want to call the shout function like we just talked about, you need to know that it returns a string. And so that's in the ABI. So when that data comes back, the ABI allows you to understand that data. And so if you want to get started learning, there's a really good tool, I think I talked about it last time, is Solidity by Example, which has a lot of good examples. You can just go to Solidity by Example, and you can go and see here on the left, there's all sorts of examples that you can see. So here's a hello world. We have a first application, which is like a counter, which we're going to deploy. There's you can learn about data types like integers, unsigned integers, addresses. So this is a really good resource for learning the language by example, right? And then on top of that, there is a bunch of really good YouTube videos that explain those in very fine detail. So there's a complete playlist of everything in Solidity 0.5 and the update to 0.8, which was a pretty big change. So I'd recommend watching these videos. There's a lot of them. So just you can watch them slowly. You don't need to watch all those videos. If you watch all those videos, it might take like a lot of time, but you can just at least watch the first few of what we're going to talk about today. So all the links are there for you to do that. That should be stuff that you just do on your own time. We're going to show off Solidity and we're going to do some Solidity. We're going to write some Solidity. So let's start out very simply. So just like any programming language, you need to be able to have variables, right? You need to have ways to store and read and write data from your application. And there's different ways you can do that. There are what are called local variables, which are inside of your function that aren't really stored on the blockchain. So in other words, they're kind of like used in a very like mutable way where you're just kind of reading maybe a variable inside of that function. Those are the local ones. Then you have these more advanced state variables. So those are ones that sit outside of a function and maybe keep track of something over a long period of time. So in other words, like a balance or like an unsigned integer would be a balance, right, of how much maybe tokens that a user has. And those are stored on the blockchain, right? And those are actually state variables and they change over time, okay? Local variables can change inside of one transaction, but they don't continue on to other transactions. So that's the kind of the difference between those two. And then there's also this concept of global variables, which are global variables are variables that are just available in every transaction that give information about the user who's calling the transaction or the address or the account. And there's also things like the timestamp for the Ethereum block, like what time was this block executed? There's a lot of different ones, but these are the most popular ones. Message.sender is the person that's calling the function. So if I'm a user and I'm trying to call a smart contract, that would be my address, message.sender. If I was to pay some value in the transaction, like if I was to maybe send in some ETH into the transaction, that would be message.value. So there's a lot of useful variables that you'll learn that you need to learn to use. There's a whole list on the docs, but for the most part, those are popular ones. There's different kinds of data types. So what a data type is just like any data type in any language. It's a certain, it has certain rules, and it has a certain implementation in Solidity. So booleans are true or false, just like any other language. Unsigned integers are basically that can store non-negative numbers. So you can store 0 all the way up to the size of the variable. So there is a limit on how much data you can store inside of a variable because of the blockchain aspect. And then integers can go negative. So you could have like, negative 100, right? And this is because you might not want to have a variable go below 0 for some reason, or you might want to give that functionality. There's different reasons why, but that's the difference. And then there's the address. Okay, so the address, everyone, if you guys installed a MetaMask or Rainbow wallet, or you have any wallet on your phone, like a crypto wallet, is an address. So that is a 20-byte identifier. It's like a 0xAB973. It's kind of this long string that is a unique address, right? It's generated using cryptography. It's basically your public key. So it's the public key that you use to sign transactions when you interact with the blockchain, okay? So addresses, you might want to store addresses of all of your users in your smart contract as they come through. Or you might want to blacklist particular users and their address. You might want to whitelist address and allows certain users only to use your application. So there's a lot of reasons why you need to store and manage addresses inside of the contract, because you might want to do access control, whatever. There's different reasons, but an address is that. It's just the actual address. And you may want to like read and write from these variables, right? We talked about state variables and we talked about local variables. So in this case, look at this example. We have a contract that is just keeping track of some number. So we have a number and it's an unsigned integer that's publicly available. So when we use this public, that means that anyone who calls the smart contract can see that value. You can make this private and then only the contract can see it. There's different reasons why you would do that, but maybe you don't want someone to publicly know what that variable is, but you still want it available inside of another, when it's called inside of a function, you could set it private. And then we have this function that just allows us to update that variable. So we say, okay, if we call set, it's going to accept an unsigned integer as this underscore num value. And it is also a public function. And we will update that number using this equal sign. So this number is now equal to whatever is passed inside of the function as a call. And if we want to get that data, we can do a get. So function get, this is also public, and you can view it, and it returns a value. So anyone can come in here and see what the number is, and we know that it returns an unsigned integer. Which is very important because we need to know how to read it from our application. So it's very simple, reading and writing, okay? And if you have questions, please hold on to them. I think it's better if we try to answer them at the end. We also have this concept of a constructor. So if anyone here has written JavaScript also has this concept of something that happens when the software is initialized. Same thing goes for Solidity. Anything you put inside of the constructor is executed at the time that the contract is created. So the way you deploy a smart contract on the blockchain is you compile down all the bytecode and you send it to the blockchain as a message. So you send in a transaction. The blockchain gets that and then processes it using whatever consensus that the network is using. which we didn't really get too much into that, but this concept of like all the nodes are working to validate what you want to do, and if you paid enough gas. So as long as you paid enough gas, you can create your own smart contract on the blockchain. But you might want to do things when that happens. Like you might want to set a variable to a certain thing, or you might want to, call another function in the contract, or you might want to call a function from another contract that you imported. So there's different reasons, but this constructor is executed at the time that you deploy the contract. So you might, the number one use for this is that you might want to set who the owner is of a contract. So let's say you deployed a contract that you wrote some cool code, you want to deploy it to the blockchain, and you want to write this app, and you want this app to be a bank. You want it to be able to store some value. Maybe it's an NFT bank that allows people to buy NFTs and give you some funds into the contract. Well, you probably need to get those funds out later, right? So you probably would want to write a function that allows you to withdraw value from the contract. Well, you don't want everyone to be able to withdraw the value for the contract, so you might set an owner, right? Who is the owner of the contract? And you would put your address inside of the constructor so that if anyone ever come in and tried to withdraw those funds, well, they wouldn't be able to because they're not the owner of that private key that's stored in your wallet, okay? So you can think of this as a really cool tool to set rules that are kind of established at the time you deploy your contract, okay? You also might want to do more complex variables. So variables like the primary data types like integers, strings, the addresses are fairly straightforward. It's just this is the value and that's it, right? You define it as a variable and you store it into the state, into the account storage, and that's it. But what if you want to do something more tricky? Like maybe you want to keep track of a particular identifier, like an ID, and then you want to map that to another variable. So you can take one variable and map it to another variable. So an example for this would be, let's say you wanted to create a smart contract that not everybody could use. Maybe you want to just only allow your friends to use it. So what you would do is you would create a mapping that says addresses to a Boolean, and then you would set true or false. So the default value would be false. So you would go through and create a mapping and update that mapping with all of your friends to have their address as true. So that's just one example, but generally that's what you want to do is you take one variable and then you kind of map it to another variable. We'll get more into this and we'll show some examples of this. But it's a way for you to create custom rules and kind of store things in a very unique way, okay? So an example will be here. So this is actually another example I said where maybe you want to keep track of addresses for blacklisting. Maybe someone's coming into your contract and you don't want them to use it anymore. So you could take their address and you could maybe set the flag to false or to true on the banned variable. So what this would do is it would set this person's address as true or false, depending on whatever you did, and it would put it in this kind of big list that you could kind of query and execute. So you could say, well, what is this address? Is it banned, true or false? And you could create some kind of custom logic in your contract. So there's lots of reasons why you might use a mapping, but mappings are very, very cool. And they're used a lot in smart contracts. There's lots more examples, by the way, on all of these things, but there's more examples here in Solidity by example. I would recommend, again, maybe going through each one of the Solidity by examples for these and watching the video. I'll try to add those in so you guys have them here in the explanation. That way you don't have to like hunt around for them. I'll do that later on today. So we talked about variables, we talked about functions, we talked about the constructor, we talked about mappings. Functions, we'll go a little bit deeper on the functions here. So functions are also a very critical part of a smart contract because pretty much anyone that's coming into a contract is most likely always going to call a function. So they're going to need to do some processing, some kind of execution, right, inside of your smart contract. So You might have public functions, which again, anybody on the blockchain could query and execute. But maybe there's that logic in there where you kind of check to see if they're banned and then you don't let them do it. But for the most part, public means that anyone can try to execute a function. And you might have internal ones, which maybe the internal ones are only accessible inside the contract or as an inherited contract. So it's hard to explain, but basically you can kind of put two contracts together. So you can deploy one contract and read in another contract that's already deployed. So if you have an internal one, it allows you to call it inside of that kind of like inside of the EVM, you can call it, but it doesn't mean that you can call it from anywhere. It just means only that another contract can call it. And then there's private, which only that contract can call. So there's no inherit thing. So in other words, if I had a function on one contract that was private and I tried to kind of come in and kind of link with that contract and call it inside, I wouldn't be able to because it's completely private. So there's like these certain rules with how the functions are defined, and they all have their own, particular reason why you'd use one or the other. For the most part, everything you're going to do in all these are mostly public. We might use private ones here and there in some of the lesson, but for the most part, everything's going to be public. We also have the ability to, let's take a look at this example. So here's an example of a token. So it's like you hear of like, whatever, any kind of token, GRT, Pepe token, Dogecoin, whatever, it doesn't matter. This is a token contract, which is keeping track of a list of addresses. So the mapping again is like kind of a list and what their balance is, which is an integer. So we're saying, okay, we want to keep track of every single address and we want to make sure we keep track of what the balance is of that address. And so we could do something like here where we set at the time the contract is deployed, we could pass across a number. Let's just say it's 100. So we pass in 100 as a value inside of this constructor. So we already know that when the contract is first deployed on the blockchain, the sender who executed and deployed that contract will get a supply of 100. So we have this balances. We call the mapping by using this kind of like syntax right here. And the message.sender is going to get that 100 tokens, right? Then we have another function that allows you to transfer tokens. Okay, so then if I was the owner, message sender here of this contract that deployed it, I would be able to come in here and send my tokens if I wanted to a recipient, right? So I could say, well, I want to give like 50 of my tokens to Vlad, right? I could come in here and I could get Vlad's address, put it in, and then I could put 50 as the amount, and then I could execute that and basically transfer my balance. So first, we can do this interesting thing where we can do a require statement. Now, some of you guys may have used JavaScript. You have this method where you can like basically require that something is true or false, or you basically can do a check. It's exactly the same thing with a require statement. We can make sure that the balance of who's trying to send some tokens to a particular user is greater than or equal to the amount they want to send. So this is kind of like a way for you to do some kind of error checking and make sure that no one's going to be able to send some tokens, even if they don't technically own them. Then we just update the balances. So we just say, well, I want to change my balance now, minus 50. And then I want to take my recipient and give him 50. And this is the very, very basic implementation of a token. It's exactly all a token is. Balances for all the addresses of anyone who holds that token. So it's a very good use case of crypto and Ethereum. There's lots of tokens. It was probably the first like market fit for Ethereum was to act as a bank of tokens, right? So if people have questions about that, I can go into more detail, but generally you get the idea. We're using the smart contract language to have some rules and keep track of variables to execute and keep track of all the tokens. So I go into more detail about all this here that I explain that. And then we also have the reference to the example. Okay, so we've talked about variables, we've talked about functions, we've talked about the constructor, we've talked about mappings, right? The next thing that you might learn about is modifiers. Modifiers are just kind of like functions, but they're required execution for a specific rule. Like it allows you to execute some other code inside of a modifier to make sure that something is passing and valid. So another good example of that, and this gets a little more complicated, but let's just kind of walk through it real quick. Same thing, we have a token. We have a balance as a mapping. So we keep track of all the balances of users as they come in and have, tokens. But instead of just kind of YOLOing this, we might at some point get some ETH into the contract. Maybe someone paid some ETH to do something. We might want to keep track of who the owner is. We talked about this earlier. This is a concept of what's called access control. It's kind of like, if you go to the bank and you want to go to your safety deposit box, or if you want to withdraw some money from the bank, they're going to ask you for your debit card or your ID, right? You can't just go to the bank and be like, oh, I'm me, just give me what I need. This is going to allow us to specifically use cryptography to establish who an owner is and doing, their public key. So this is a public variable, but I'm saying public key, which is the owner's public key. And I can have a modifier that says, well, we want to make sure that only the owner can be called when a modifier is requested, okay? So in this case, we say, we require that the sender calling the function is equal to the owner that we've defined at the time we deployed. If not, we say you're not the contract owner, and we kind of cancel the execution of that function call. So it's a way for you to do kind of like a check. So in this case is a really good example of access control via modifier. And so at the time that we deploy the contract, the last time we just set the supply, right? We just set the supply, which is fine. But now we want to actually set the owner. So we want to set who the owner of the contract is. So whoever deployed the contract is going to be in this variable called message.sender. And at that time, when the contract's deployed, they're the owner. They own the contract. Then we still have the same function, right? Which can do the transfers that anyone can call. It's public. It's a token. But what's important right here is we have this ability to mint new tokens. So if I wanted to come in and we had 100 at the time of the deployment, and then I gave 50 to Vlad, but then I come in and I'm the owner of the contract and I want to add 10 more, I could do that because I can come in here and say 10, but only the owner can do that. And I could update the owner to have 10 more tokens. So think of this like the government or some kind of institution might want to print more dollars, right? Or print more, I forget what the currency is in Serbia, but they might want to print more like actual currency. Same thing, we're going to mint some tokens. So, but we don't want anyone to be able to mint tokens because then what's the point, right? So you can think of this like only one person can mint those tokens. So it's a really cool way where we use the modifier. So here's the modifier that says who is the owner, make sure that they're the owner. And then when we want to mint tokens, well, you have to be this only owner modifier. So this has to execute true. Otherwise, you won't be able to execute this mint. So there's some cool stuff you can do with modifiers, and you will use modifiers in the rest of this course as well. Okay. So now let's do some hands-on stuff real quick. We got about 10 minutes, I think, to do something interesting. So what I'd like to do is just really quickly, I'm going to set up scaffold ETH like I normally would. So I'm going to do npx create -eth at latest like this. And it's going to ask me if I want to install the package. Usually we've already installed that, so we don't need to, but we're going to call this one counter. Enter. Going to install the chain. I'm going to use hard hat. So this is the exact same thing I did last time, just setting up a new scaffold ETH project. Okay. So this is going to install the dependencies. It's going to get me install Yarn. Well, it's going to use Yarn to install Hardhat. It's going to use Yarn to install all the dependencies for Hardhat and Next.js. And it's going to format all the files in a nice, pretty way. And it's going to give me an empty Git repository that I could upload to Git if I wanted to when I'm all done. Very handy little kind of installation script. So that might take a second. We'll give it a second. But what we're going to do is we're going to go to Solidity by example, and we're going to go to the very first app right here. Okay, so everyone should do this later on today or later next week, or I should say later this week. And you should try to implement this inside of Scaffold ETH. Okay, so we're going to do that. Let's see if it's ready. Still not ready. I'm on the hotel internet, so it might take a while. But we're gonna take this. So if you're on Solidity by example, we always name the contract in Scaffold ETH your contract, okay? So what we can do is we can just grab all the stuff inside of the contract. So we don't need to grab the version of Solidity. We don't need to grab the license. We don't need to grab the contract object, which is this part and this part. We can just grab the stuff that we care about, which is the integer, the functions, and that's it. So I'm going to copy that, okay? So now Scaffold ETH is done. So let's go into that counter folder that I created. Let's start up the chain. So same thing as last time, we do yarn chain, which will start up our blockchain. Then I'm going to split my screen up. You guys can just open separate windows, but you need to have a few windows open, right? So I'm going to go into the counter folder on this one. So this one has my blockchain. This one will have my front end. So yarn start. So yarn chain backend, yarn start the front end. And then we'll go into this window again and go into the counter here. I'm not going to deploy the contract yet, but normally we would do yarn deploy, and that would deploy our contract. Actually, you know what? Let's do that. Let's deploy the contract so we can see that it's working. And it's a little slow right now, but there it goes. Okay, so now let's open the code. We deployed the contract that came with Scaffold ETH, but we actually want to write this other code, right? We want to use the code that we just got from our thing here. Let me hide these meeting controls real quick. Okay, so we want to go into the packages folder. We want to go to Hardhat, and we want to go to contracts and go to your contract. So all Scaffold ETHs come with the same setup, this basic contract. Let me zoom out a little bit. So what we want to do is kind of just gut it a little bit. So I want to take away some things so it's easy for you to read. So I'm just going to wipe out the comments for you. And I don't really need, well, we'll keep the console, but I'll get rid of some of this stuff. We're going to get rid of everything inside the contract. So we're just going to wipe it out. There we go, like this. So now it's just an empty contract, right? So now we can take that code that we have on our thing, which is here, right? And we can just paste it in right in the middle like this and save it. That's it. Now, if we try to deploy it, we're going to get an error for a couple of reasons. One is that our deploy script is trying to call the information that's in our old function. So all the stuff that I deleted. So let's go to the deploy script right below. My computer's acting up right now. I don't know why. There we go. Go to the deploy script right below inside the deploy folder. And let's look at that real quick. Same thing. Let me get rid of some of this syntax real quick. So let's get rid of this. Let's get rid of this. Okay, let's get rid of, yeah. So this is what we're doing here is we're deploying the contract. And earlier I had a constructor which was taking arguments. And so you'll notice if we look at the error, this error, you can't really see it very easily, but it's basically saying that it expected 0 arguments, but we're trying to pass in a variable as arguments in the deployment. So this is what a Hardhat deploy script. I didn't really show this last time, I don't think, so I'm going to talk briefly about it. But the way that Hardhat deploys contracts is using TypeScript, okay? So this is a TypeScript file, and what it does is it uses Hardhat to deploy a contract using deploy your contract here. You can set variables just like you do with JavaScript, right? It's TypeScript. So what we do is we get a list of the deployer accounts that come from Hardhat, which are basically the contracts up here. So our hard hat comes with, when we first started it, we got all those private keys and public keys. So this gets the list of keys that were kind of established. You'll get more into this, but that's just kind of how we get the deployer account. And then we do that by calling HRE, which is hard hat get named accounts. And then we use a deploy variable to do deployments. And we call the contract your contract. We use that deployer here as the owner. Okay. So remember we talked about who deploys the contract gets the, basically is the owner of the contract if you set it that way. So this is the message sender, basically the deployer, which comes from hard hat. But we also tried to pass the deployer as an argument, but we want to get rid of that. So we just want to take that argument out. Okay. And if we save that and try to deploy again, let's see what happens. It's going to give me another error. And this time it's going to tell me that I'm trying to call something in the contract that doesn't exist. Now, if you notice, it's right here. It's trying to log something to the console by calling the greeting, but I deleted that. So we're just going to get rid of this stuff like this. You'll understand this a little bit more. You don't need to know too much, but basically we're just kind of fixing the deploy script by removing the requirements and removing the function we deleted. So if you guys follow this at home, you'll be able to then, get it squared away. So now if we deploy, it should work. Let's try. There it goes. So it was successful. So we deployed the contract and it's available. So let's look at scaffold ETH. So let's go to localhost 3000. A little slow. So it has to compile the front end. So now it's loaded. Okay. So now it's here. So just like last time, we had a contract deployed. So scaffold ETH again is Next.js. So it's this front end. But the cool part of scaffold ETH is two things. The burner wallet. You notice we don't need to use MetaMask. We have this kind of burner wallet. And then we have this debug contracts thing here. And now, if we look at our code, it should match what's available here. So let's look at the contract. What is it? It's a counter. It has a variable called count, which is an integer, unsigned integer. It has a function to get the count, return it. And it has here, so it returns an unsigned integer, which is the count. And then we have a function to update the count. So like add 2. So all we do is we add 1. Then we have a decrement. So we can decrease, right? Decrease the value by doing a minus. So that's all it is. It's just a counter. You can click a button and increase it by signing a transaction or decrease it, okay? So that's what we see here. We have the count and we have a write function to increment and decrement. So if I click increment, it's not going to work because I don't have gas. So just like, as I mentioned before, you have to pay gas to do anything that writes to the blockchain. So because we're using this like virtual environment, we have a faucet here. We can just grab some funds from the faucet. So that comes from our local hard hat node. And now we can increment here. There we go. So now we're able to send these transactions. Yep, boom, 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 as many times as we want and bring the count all the way to 20. And if we want to go back all the way down, we go all the way back down to 0. And we're putting that 0. Now, what do you guys think is going to happen if I do one more decrement? Let's do it. It's going to give me an error. I'm trying to take that integer and I'm trying to turn it into a negative number. And so I got a panic, what's called an underflow or overflow. Now, Solidity is very strict about that because we don't want to allow a user to make a negative number. They might do an exploit or something. So in order to fix that, we would have to probably change it to an integer. So we could do that. Let's change everything to integer. Integer. And let's see if that works. Returns integer. Integer. That should work. Let's try it. Redeploy our changes. So you make some changes, you come in here, you deploy them, and then you see if it works. So now we have we kind of get reset. We still have our faucet funds. But now, if we go negative, boom, we can go negative because we're using an integer now, not an unsigned integer. So just a neat little trick. You can kind of understand how integers and unsigned integers work. Okay, so Everyone should be able to do that, go through that process before our next session so that you get comfortable with understanding Solidity, how to write it, and understanding how the deploy scripts works. Again, you don't need to know too much. I think the most confusing part to probably everything I just showed you is this deploy script. But again, we got rid of the arguments, so we had to delete this argument. This is all in the instructions. And then we also got rid of the console log that was right here as well. It was like somewhere in here. So you'll need to do that to get it to work. And then this is what the deploy script looks like. It kind of walks you through a little bit about that. There's some more cool examples in here, like how you could make a bank smart contract, right? Here's a bank. I talked about that a little bit in my example, but this is a very simple bank. Here's like a bank where it has a fee. You might see like, oh, well, how do you do a fee, right? For people to use your bank. This shows you how to do it. So there's some cool examples you can toy around with. But before the next session, what I'd like you guys to do is go through everything I did here, read the example documentation from Solidity by example for each of those sections. So variables, data types, functions, modifiers. Those are all the basic things that you really need to understand when you first get started. Require statements, understand how require works, and then try to create your own contract, right? So I want you to try to use the syntax that you have available to make something interesting. You could redo something that we kind of did, but come up with like an interesting idea. I have a whole bunch of examples. I thought I did. I'll put some examples in here as well, within the next day or two, of things you might want to create that are kind of easy to do. But just, yeah, have fun with it. Just try to deploy something simple. But take the time just to understand the syntax of Solidity. So I like to just go through Solidity by example, look at each thing, look at the YouTube video for that example, and then go from there. Okay. Okay. So now I did a lot of talking. I think let's try to like answer some questions if people have them. Otherwise, I can also talk a little bit about what we're going to do next time as well. Or if we could also look at speedrunning as well.
And for me to jump in,
Yeah.
Plenty of things to do. I just saw like mapping, like adding some videos. That's cool, and to have some different examples like for homework for people. That's a cool thing. I think for this session there is plenty to grasp, especially for the ones that never had any experience with this type of things. So I hope, not hope, but we expect like a separate session with the participants with answers and Q&A session, and also Discord. They all have a link to Discord. Please join, and that's where all the action will be in between with all the questions. But don't mind me. If any of you guys have any question now, it's okay to ask Kevin for this session. Shoot.
Can you hear me?
Yeah, I can hear you.
I have a problem with installing Scaffold completely. I tried to make a project, but on the third step, it says failed with exit code 1 yarn installed. I tried reinstalling NVM, npm, node, yarn from scratch like 2-3 times, but it still doesn't work. I don't know why.
Okay. So what you could do is, are you in the Discord yet?
I think I am.
Okay.
I think I am.
If you're in the Discord chat, drop the exact like error, like all the stuff in there. And then I can help you like just kind of remotely. Probably something fairly simple. Are you running a Mac?
No, Windows.
Windows. Okay. Did you try installing the newest version of Yarn by chance?
Yes, I also tried upgrading it and still no.
Okay.
No.
Yeah. Then I just need to
Oh.
probably see what the exact error is because exit code 1 is like very generic. So it might be that, there's some kind of package dependency. Are you using WSL Linux on Windows?
I installed WSL, but when I try to run the terminal, it doesn't even register the create if latest command. And I have Ubuntu, how's it
Mhm.
pronounced? I don't know. And there it works, but then it just fails in the first step completely.
Okay, let's try to do it async because it might be that we need to go back and forth and kind of look at your code and see what's
Yeah,
going
yeah,
on.
sure.
I'll give you some stuff to try. But yeah, just pop into the Discord. There's the Web3 challenge section. A lot
Yes,
of
yes.
people get access and go to questions and answers and put it in there, and I'll try to reply. It might not be today, but I'll get to it tomorrow.
Okay, okay, thank you.
Mhm. Cool. Any other questions that you guys have?
Like any other takings? Oh, okay, but generally, okay. I had also a couple of things, especially I'm running on a Mac, so I experienced some bumps on the road. So I advise everyone just either screenshot with the question, whatever. Kevin is there, others will jump in. So you will have the answers. It will be more quickly, especially the intro part, and then we can play.
Absolutely. There's also another link in the Notion for the Telegram developer chat. You could also ask in there. They're pretty good, but I'm happy to try to do it first, and then we can kind of go from there.
Cool. Could you go just in quick notes about the next session, what to expect? And okay, we know about the homework and this first session. So let's wrap up this session with what to expect in the next one, and
Yeah,
what we achieved so far, like in really short terms.
yeah. So the initial section was all kind of intro to like what Ethereum is. The idea was for you to go through, learn all the lesson, watch the videos, kind of understand like how Ethereum works from a very high level. The homework was to try to go to speedrunethereum.com, connect your wallet. So if you have MetaMask, you need MetaMask installed. Just go to start a challenge and try to complete this very simple quest. This takes like, if you get Scaffold ETH up and running, you should be able to do this in like probably 20 or 30 minutes. It's very, very easy to do. Get that up and running and try to deploy it. We can go into more detail about that, but this is more of like an asynchronous thing where you kind of want to, this is kind of test to make sure you set up Scaffold ETH properly. Today we went into session 2, which is basic understanding of how EVM works, what is the Ethereum Virtual Machine, how it processes state and updates state. We talked about Solidity language and Solidity syntax. The next time we will do session 3 is going to be very similar to this workshop, but we're going to actually write a smart contract from scratch. So we're going to actually build a smart contract and walk through the entire process of adding every single thing that we need to do and deploy that smart contract. And then we will talk a little bit about what a token really is, an ERC20. We'll try to create that token. We'll talk more about that stuff, but we'll also talk about events, which is interesting, and we'll talk about kind of like how you should really build a contract to make it work. We'll talk about functions and how you use the call and transfer and send methods. So yeah, and then we also have the cheating way to look at the source code, but we're gonna see if you can do it yourself. And then the next thing, and maybe tomorrow, or sorry, next time we meet, we can do the challenge 1 of Speedrun Ethereum as well, and just show what that looks like as well.
So I think that's a wrap for today. Okay, on behalf of Pupin's Web3 challenge, I thank you all for participating, and we expect a lot more people looking through this material back home, and others from region. Please join Discord channel, ask questions. Let's prepare for the next session. We have 2 weeks. In the meantime, we will probably hold another session somewhere. Just track the Discord channel and the groups that we have for this. Kevin, thank you so much for your time.
Yeah, no problem. Thank you, everyone, and enjoy the rest of the holiday.
Thank you.
Bye, guys.